Let's do a few examples involving parallel lines. So first, before I even get started here, I need to draw my transversal that cuts through these lines. And now we can go ahead and label the different angles. So I'll label these in orange because why not? Maybe a little bit smaller brush size. 1, 2, 3, 4, 5, 6, 7, and 8. Might even zoom out just a little bit so that we can see that and see our table below. Okay, now I want to label what are the corresponding angles, what are the alternate interior angles, and what are the same side interior angles. And I'm going to use colors too, because I like to, why not? So, corresponding angles. Well, angle 1 and angle 5 are corresponding. Remember, if you were to draw a kind of a box around each of these, should be the angles in the same spot. So you can see angle 1 and angle 5 are in the same spot. I don't even know if I'm going to have enough colors. Angle 2 and angle 6. Sometimes it's tricky for me too to figure it out. Angle 2 and angle 6, angle 3 and angle 7, and last but not least, angle 4 and angle 8. Those are all corresponding angles. Okay, and maybe I can write a little bit smaller as well. That might be helpful. Okay. Now, what about alternate interior angles? What about that? Well, here we go. Doing what we can here. What about alternate interior angles? Well, remember, the interior angles here would be 3, 4, 5, and 6, these ones on the inside. And alternate interior angles are the opposites of each other. So, for example, angle 3 and angle 6 would be alternate interior angles. So would angle 4 and angle 5. Those would also be alternate interior angles. Okay, same side interior angles. These are interior angles. Again, interior means on the inside of the parallel lines. And they're on the same side of the transversal. So angle 3 and angle 5, angle 4 and angle 6. And remember, this is probably important for us to write. Corresponding angles are congruent. Alternate interior angles are congruent. And same side interior angles are supplementary. It's really important to remember that they're not all congruent, right? The same side interior angles are supplementary to one another. And this right here, really, if you can get this down, these corresponding angles, the rest should at least fall into place. Because you could think about vertical angles and supplementary angles improve the other things. So I think being able to recognize and see corresponding angles is probably the most important skill that I'd like for you to take from this, from these notes maybe. All right, so let's look at some of these and just see what we can see. Solve what we can solve. And I'm going to zoom in because, at least for me, I don't know about for you, but some of these are kind of hard for me to see. Maybe even one more. Okay, so let's look at this one right here. There's a number of ways you could solve this, but right off the bat, what can I say about my angles? Well, I know that I have some corresponding angles, right? Again, I really like this idea of just draw a box around that, draw a box right. Oops, gets me every time. Draw a box here, and then you can see, okay, this part, maybe move it a little that way, but you can see, right, this part and this part are corresponding, this part and this part are corresponding, here, 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 and here. So AD is equal to 2y, and then whatever this is equal to x. Well, I know that these two are on the same line and are supplementary. Oops. So then I should be able to say with some degree of confidence, some level of conviction that that's 100 degrees. So then, okay, 2y equals 80 and x equals 100. That means y equals 40. So there you go. Y equals 40, x equals 100. Just like that. All right, let's look at this next example. And we'll see, in the future, we'll see even more figures like this, but this is pretty good. It is a triangle, and, well, maybe I can leave that. It is a triangle, but really I want you to focus on these parallel lines and the transversals that cut them. Okay, so let me, I don't know, this is kind of what I like to do. I'm gonna draw this line through here, draw my parallel lines in orange. Because the interesting thing about this is that I have two different transversals. I have a transversal here, and I also have a transversal here. That wasn't my best work. Okay. So here I only am looking at the corresponding angles between this green transversal and my orange parallel lines. And as you can see, right, again, we have, I'm not going to do this every time, I promise, but I think that it's worth seeing, right? We've got this and we've got this. So my corresponding angles, these are corresponding angles because they're in the same place. So then x is 60. Now let's look on our blue line. These, what type of angles are these? Well, y and 50 are same side interior angles with the blue line and the orange lines, right? I don't really care what's going on up here. So that means that y plus 50 is equal to 180, right? They're supplementary. So then y is 130. Okay, so it's important to note sometimes you're going to have multiple sets of angles, and that's okay. Multiple sets of transversals, that's fine. Keep your eye on the prize, take it one step at a time. Maybe use colors, I don't know, helps me. All right, let's look at another. We can go over here. Let's go down here, why not? Okay, so I have this right here, this parallelogram. Well, I actually don't know that it's a parallel. I actually don't know that it's a parallelogram. I know it has one set of parallel sides. And this is the trick. I don't know that these are parallel. So again, I'm gonna do what I did last time. I know that these lines right here, I know that is parallel to that. Maybe I can do a little better on that one. There we go. I know those are parallel, and I know that they're cut. They're cut by a few transversals, honestly, but the one that I care the most about is this one that goes right through the middle. Right? These other ones, I don't know quite as much about. I at least don't know that they're parallel. So I'll go ahead and draw them in, but I'm going to do different colors. Because, again, I really just want to highlight the idea, I really just want to highlight the idea that they're not necessarily parallel. There's nothing that I can do, at least right now before I've started, to say that I know that these two are parallel. Okay, and we don't know anything about triangle angles yet, so this will be kind of interesting, but I think it'll be solvable. So hopefully you're noticing something right off the bat, right? I have some alternate interior angles with 2y and z, 5x and 5x and 50. So I know, I don't know, 5x is equal to 50, so then that means x equals 10. I can also say 2y equals z. That's really it. That's all I can say there. Okay, now there's something else, so, and maybe I might even write in over here that that is 50. Because there's something else I want you to notice here. if I take this entire angle, if I take this whole angle, well, that whole angle is an interior angle of these two orange parallel lines and this blue transversal right here. So then, and that angle is 2y plus 5x, or 2y plus 50. I know that's kind of like, whoa, that's maybe a little bit much, but I know that that's 2y plus 50. So I could say that this angle right here, right, this angle, this whole angle right here, both of those, is supplementary with that angle right there. Again, this whole angle, 2y plus 50, is supplementary with 110. So let's write that in blue. 2y plus 5x, or we said that it was 50, plus 110 is 180. It's supplementary. So then 50 plus 110, well, that's 160. Subtract 160 from both sides. 2y equals 20, or y equals 10. And then earlier we said 2y was z, so then z is 2 times 10, or 20. So we have z, we've got y, and we also have x. And the trick there, again, is to see that these two add to 50, these two add to make this one angle, and that this angle, 2y plus 50 and 110, are supplementary. Now, maybe you've done some stuff with triangles in the past, and you could say, well, I know that 110 plus 50 plus 2y is 180 because of the fact that it's a triangle, right? And you could do that. You totally could. But we can also do it using parallel lines. We can solve this question using parallel lines. Okay, we've got two more. Okay, this one is a little wonky. I have 110 over here. I know that these lines are parallel and these lines are parallel. So here, this is interesting. I'm going to go ahead and use, again, wouldn't it be right if I wasn't using some different colors here. So these two are parallel. And then these two red lines are also parallel. Okay, so maybe you're noticing, I know at least I'm noticing, that you have a few different corresponding angles, right? You've got this box is corresponding with this box right here. So all of these angles are congruent to all of these angles. And all of these angles are congruent to all of these angles. So it is interesting that doing that, you can see, well, these angles are also congruent to those angles. So, but let's just take it one step at a time. So I see that I've got the blue lines cut by the red. 110 and x are corresponding. So I know that, let's use blue for this one. I know that 110 is equal to x. Pretty nice that we already know what x is. And then here, I know that 2y is equal to x, which is equal to 110. That's some nice transitive property of equality right there. If I divide this by 2 and divide that by 2, y then is 55, right? So y is 55 degrees. 110 degrees is equal to x. And that's all from corresponding angles. Okay. Yeah. Last one. Here, I know these two lines are parallel, and I know this is perpendicular to this line. Now remember, one of our reasons was that if I have two parallel lines and one line is perpendicular to another line, then let me say this again. Two parallel lines, a line cuts through both of them, and that line is perpendicular to one of those parallel lines, then it's perpendicular to the other one. So right off the bat, I already know that this right here, that's perpendicular. So x is 90 degrees. And then Well, these two are supplementary. So again, 3y is also 90, or y is 30 degrees. Just like that. So hopefully that's a little preview of what it looks like to use all these different properties of parallel lines to actually solve some questions with them.